Hi there everyone, this is Sarah. Welcome to our webinar today. Today's topic is critical controls, safety differently. So before I introduce our presenter, just to let you know that if you have any questions, please use the Q&A panel. We might invite some feedback using the chat panel. As with all our webinars, it does attract Australian Institute of Health and Safety CPD points if you are registered for that. We will record the webinar and share a video and podcast via email later today, and also in the HSCQ news tomorrow. So I'd like to welcome Kelvin Genn today. He is the Art of Work's Managing Director. He has spoken at a webinar, I think last year, on a similar topic. He is a strategic systems thinker with experience in human factors and organisational re-engineering. He developed his systems thinking approach working in the Royal Australian Air Force for 10 years. Following this, for 10 years, he led systems and risk management programs across Asia Pacific and Europe with Compass Group Plc, the world's largest support service company with more than 750,000 employees. So without further ado, over to you. Thanks for joining us, Kelvin.
Thank you, Sarah, and thank you for the invitation to share in this discussion today. It's something that we're very passionate about, this idea of critical controls. And at Art of Work, we became really interested in exploring the idea of critical controls in the light of safety differently and applying a safety differently lens to the critical control concepts. So I'm going to start my presentation from just posing the question is, well, what's wrong with critical controls as we currently structure and manage them? And I'm going to put a few of my perceptions and insights and experience around the space. If we look at how we present critical controls to boards and executives, typically what we tend to do is to go through a process of identifying our material risks and in those material risks attaching critical controls to that, and the premise being these are the controls that are required to effectively manage the material risk that's attached. And then we go through a process of feeding back a risk assessment of that process. And if we typically look at these risk assessments from an executive point of view, what they will see is the material risks, the critical controls, and a residual risk outcome that tends to look like the risk is low or very low as a result of the critical controls being in place. And I think what that does is, firstly, it creates a false sense of comfort in terms of the executive understanding what the actual transactional nature of the risks are in their organisations. And secondly, it misinterprets the reliability of the controls that we design and put in place. And what we've discovered, there's a lot of flaws and a lot of assumptions that are put in place when we go through the process of designing and implementing critical controls. And I'm going to examine those in a little bit of detail. I'm going to start this proposition thinking about this question then. What is it the board and leadership actually needs? So if we go back to the obligations that they're required to meet, their obligations of due diligence, the 6 elements of due diligence that is codified within the Model Act, and this is in essence, what they will be tested to demonstrate in the event that there is something that has not gone as intended. So if you think about the critical control component within, what they're obliged to do, firstly, is to understand the nature of the hazards that exist within the organisation, the control strategies that are in place, and how well those control strategies are working, how reliable are they in essence. They also then need to understand, are critical controls appropriately resourced? Has the right level of resource, and that might be within investment from capital into the place. It might be investment into the management and compliance of these processes, but they need to be able to demonstrate that they understand that they have appropriate resources. They also need to be able to demonstrate that there is a system of monitoring the performance of controls. And finally, you need this, it's sort of interlocked in some way, but a process of understanding, how the system complies. So in terms of how critical controls are being transacted and complying with the way that they've been designed and set up within the safety management system. And then you need a process around the verify. Verify often gets interpreted in different ways, but part of the key element of verification is understanding how the controls function where the work is done, and having some verification back from that place. And when we think about and look at our critical controls and apply these tests, I think they often fall short of meeting this obligation and giving board and leadership the information that they need to provide useful contribution to establishing better and more reliable critical controls in that space. So when we started on this journey, we thought very much about, well, who gets to decide? Who decides what the critical controls are, and who decides as to how those critical controls will be deployed? And I think in the majority of experiences that we see, we would see it's what we would term subject matter experts. These will be safety people, they may be engineering people, but in essence, they're people with technical expertise in the safety and the application of safety in that domain. And within that process, the method that we often sort of deploy, is using bow tie is pretty typical out there in trying to understand the hazards and understanding the threats and understanding the control strategies that are in place. So we see these deployed. I think typically, again, when we see this bow tie analysis process done, it is done by subject matter experts. And the other, I suppose, component of this is how often is the control performance information reviewed in terms of the bow ties. So typically with bow ties, we see it's an exercise that is done at a set point in time. It might be every year or every couple of years where bow ties are put in place. The design process goes through, and in essence, it tends to get filed away and doesn't become part of the lived experience of control performance. So it has a very narrow view, and it really comes from the view of the subject matter experts. And then when we look at the nature of controls, I think it's interesting to understand how do we assess them. So when we're looking at these control strategies and we bring it in terms of a risk matrix, which is fairly typical in this approach. We have this approach of trying to interpret a control. I'm just using the example of a swim, for example, and the safety, our subject matter experts will go through a process of understanding the nature of the risk that's and the hazard that's being addressed, looking at the potential consequences that it has applied, and then looking at the application of the control, and then determining what the impact that will have on the potential consequences as such. And so we ended up with these ratings. So if we take a swim, I think it's really interesting how we sort of examine this and how we interpret it, and the assumptions that we make that a procedure by its nature can be interpreted as a highly reliable control. The question is, how do we know that? How do we know that the swim that's in place actually performs? Is it fit for purpose? Is it well designed? Is it used? Rather than we can get into a myopic sort of situation where we think that all procedures are good procedures, and once they're applied, all that needs to happen is that the user of that procedure needs to comply, and the control will be satisfactorily executed in this space. So as we've went and explored this process, and we've had a lot of experience in this space, it's really interesting the diversity of opinion, or opinion and practice out there about the concept of what a critical control is. And after going through many workshops in this space with subject matter experts, it is quite interesting to see the interpretation around critical controls. So I thought I would use an example, and I'm going to take an example out of the food safety process, because I think it's been nicely executed within food safety, this concept of critical control. So the first thing that we would say about this process is that a control is essential to preventing the loss of control of a damaging energy. And I'm going to come to explain that in a moment. But in the food safety context, the process is HACCP. People commonly see that organisations are certified for, but they've got this method of hazard analysis critical control point. And in that, what they're trying to understand is what is the hazard that sits within the food production, and then what is the critical control point that will ensure the safety of the food. So the most common one that sits in this space that we will see out there is they've identified temperature, that the storage temperature of the food, and it's in two conditions: that when it's been stored, that it is less than 5 degrees Celsius, and when it's being prepared and heated, that it's heated to 60 degrees or more in the cooking process. And that would establish, that's the critical control. That's the control that we go and look at to see that's in place when food is being produced, that the production is actually achieved. There's obviously more controls in this space, but as an example of a critical control, I think it works quite nicely. It's, to me, that's a clear critical control. If we look at the another context, and we said that the control was the training and competency of the food handlers to ensure that the temperature control is made, that would not be a critical control in our interpretation. Now, it has a place in that control, but it's not the critical control. The control itself is the temperature control that you're looking for, and then you'll look at ways to supporting and make sure that control functions carefully. So part of this process is to reframe and be clear about what we think critical controls are and are not, and how they fit. When we're looking at our control strategies, how the controls that we design fit into this particular context. So in going through this process, we've given a lot of thought and done a lot of work and a lot of design in this space to this question of what we really want to know is, how do we achieve control effectiveness? If we've got a control in place, how can we be confident that that control is actually working? How reliable is that control? And in doing so, we've brought in some of the elements of safety differently to achieve this. Now, what's interesting in this space is there is a real bridge between some of the processes that sit within a safety 1 domain and some of the processes of safety 2. And in this exercise, there's an active marriage between these two processes. It's not about doing one thing or the other in that context. So the first part of the principle that we came to review and apply is principle 1 from Safety Differently, is that people are a solution to harness. And the question then becomes, how do we actually bring that principle to life within the context of critical control? And then the other concept that we really work from is, what we really wanted to understand is, how do we understand performance? How do we understand controls as they perform in the system? What are the things that people depend upon to make the controls work? Whether it be the tools, the resources, the skills, and understand conditions and constraints, and make sure that we inject that into our thinking. So embarking on this path, we've stepped into the process of using human-centered design as being central to the control effectiveness process. And I'll show you how this works in practice. But fundamentally, the concept of critical control is now based around the user and using the human-centered design to understand the user experience and all the work that sits around your experience. So the diagram that you're looking at here on the screen comes from Stanford University, the Design Council, and it's those who are familiar with this process, it's a standard template for doing human-centered design. So within the critical control methodology, we've adapted this, and where you're coming into that is starting from a control that you're looking for, and then you're going back to go and test it with the users of that control. Is you want to understand and listen to them. You want to understand the view of the world about those controls, standing in their shoes, so you can empathise with that process. Once you've done that and collected some information, you can think differently and start to redefine and come up with new ideas. And once you've developed some ideas, you can take those ideas and go out and test them and put them into place. And where you see successful response to that, you can then go and widely, make a change to an existing system or deploy a new concept across the organisation. But the whole premise of this is if it's coming very much from the perspective of those who use the controls as being really central to the design process. So go back to that question now about who decides on a control. And what we're now going to try and actively achieve is the integration between the two groups. There's a clear role for subject matter experts in this space, but what we discovered is subject matter experts need better intelligence. They need better data to work from. And that data is the data that they can get from the users, the end users of a control. So the process is trying to reverse the model, go to the frontline experts first to harvest some intelligence and some insight in that place, and bring that information, back to the subject matter experts, so they can understand the controls and how they perform in a different way. So in redesigning this process, we went back to some of the basic concepts. So firstly, in designing our understanding critical controls, we went back to the Haddon-Viner energy damage model as a way of actually classifying and understanding the critical controls. So we went back to this idea of understanding what are the damaging energies that we're working with, and then working in terms of a human-centered design model to actually understand our control strategies within that space. And the principle being is that ultimately we're trying to prevent the expression of a damaging energy in a workplace, in the environment, or for people who are working within that context. So on this, we've sort of been working and mapped up an extended list of what that damaging energy might look like to help with the classification process that we work with. And the next thing that we went back to is the hierarchy of control, which is central to, it's in all the legislation, and we have to deal with it. It's a very safety one model, but I think it hasn't been well understood in this process. So we've tended to treat the hierarchy of control as independent steps, so that you're either one thing or the other. You're either an administrative control, or it's an engineering control, or it's a separation control, or it's a substitution control, or ultimately you've stepped into the elimination of that process. When we worked through and redefined our thinking around this, we discovered it was rare for a control to stand in its own right. It's extremely rare for an engineering control to not have significant human factors elements, and therefore be very dependent on people, a human dependent control. And by its very nature, we then say, well, if we're understanding controls, you need to actually merge these two concepts together. You need to look at the engineering control and what is the level of human dependency that is in the design of this control. And the principle being still within this fact that the more, let's say I'll go to less, the less human dependency that you have in a control, the more reliable that control will be. So the more it depends on the capacity, skill, the training, following a procedure, doing a whole lot of sequential actions, the more predictable it is that control will fail at some point in time. So where we ended up with is designing a system of understanding control effectiveness, and we've broken this down to a set of points to understand controls, and I'll go through these in a short summary in a moment. But the idea is, firstly, we want to understand what the robustness of the control is, and this is a combination of the hierarchy of control and its dependency on human factors. We want to understand the alignment of the control, and this is how it fits with how work is done. We want to understand how adaptable the control is, and also where we've got human dependency, we want to understand how well or how poorly that is designed, and ultimately we'll come up with score to give an analysis of a control. So, like I said, the first element's done when we go through this and we establish we're looking at a critical control. First thing that we do is, with the subject matter experts, they will determine the hierarchy of controls and some other features of that. They'll also determine what are the organisational factors that are relevant to that control, and that will end up with an assessment of robustness in that space. Now, what we're looking at in this place is this idea of the interconnection between hard controls and human dependent controls. What we're saying in this model is hard controls don't equal robust and effective controls, because they're dependent on these other factors. On its own, if you take the hierarchy of controls in isolation, it's missing a whole lot of other features in this process. Is without the support of people, these hard controls are not very effective. So what we're then doing is saying, well, there's a set of human factors that are attached to this process, and to make the controls reliable and effective, we have to take these human performance factors into account. Everything that ranges, from safety culture and change management and these processes to fitness for work and workload. These are all the standard human factors that we assess. The human factors that we built into this model have been drawn from the Western Australian Department of Mines, Industry and Regulation, the MIRS. So these are the 10 factors, quite a bit of information, but there's a number of models in this space that work. We've chosen this particular one. You could choose the Keel Centre, for example, or others. But for our purposes, we've used these as our process. And then what we've done is saying, the first thing that we do is let's understand, where the control sits in terms of the hierarchy of control. And then we go and check against the system of what are the elements that this control depends on. So we simply go and check, is it dependent on human reliability? Is it dependent on permits, procedures, training, the like? And we simply check those in to understand it. The idea being, if you've got all these dependencies in all these areas, you're looking at a less reliable and effective control. But if you're looking at a control that doesn't have these dependencies, so in this case, we've just chosen a substitution control, and the only dependency it has is maintenance inspection, we can conclude that is going to be a more reliable and effective control in its nature. So what the key to this is not saying that those are right or wrong, but understanding, the level of dependency is going to change how we interact with the control. So when we then go to look and think about the human dependency element, so there's two things, and this is where we bring in user-centered design in this process. Now, for the human factors part of the session, that's where we use subject matter experts, and for the user experience mode, this is where we use the end users of the control. And in the process, what we go and do is we test with the users things like, how discoverable the control. How do you know that you have to use the control? You might design, does the control work Is it well designed for the work that you do? And a range of things. There's 5 factors that we take into a place, but we go and test with them in using this control in their settings. How well does it work for them as a user? The next element that we test, and this is all done with the front line, is the alignment of the control. We want to understand, firstly, whether the control helps or hinders the individual worker. Does it make it easier for them to do the tasks that they're working on, or does it make it more difficult in that space? So what's interesting about this, when we look at the scores about this, it starts, well, the combination of those. I'll go to the other one first, I'll come back. We also want to understand whether control helps or hinders the objective of the work that's been done. So does it make the task being complete that needs to be done easier to get done? So this is the broad objective of the piece of work that's been done in that context. So when we look at the combination of these, if you get a control that the workers feed back to you that it hinders their work and it also hinders the nature of the task that's been done, you can reasonably predict this is a place where you're going to get work around for a control. So this score is quite useful in understanding the better you design controls. And I would use an example here like scaffolding as an example of control. If we test scaffolding with construction workers on a fixed building, it scores quite well because whilst it takes some effort to put in place, workers actually, it makes their job of doing the construction a lot easier, and it actually helps the construction task that's been done. If we're looking at scaffolding and doing maintenance on a building, it scores pretty poorly because it takes a lot of work and effort to put in place, and people will find workarounds to put in place. And this is where you get misuse of ladders, whereas an elevated work platform will score quite well in this context. So this system is quite good at calibrating those sorts of issues. The final element that we analyse and look at is response to change. How adaptable is the control? So particularly where you got conditions that are varying or different operational needs, the control adaptability can be quite important. And again, we take this feedback from those who use the control to tell us, how easy it is to adapt to the work and how well can they recover when something doesn't go right with that control. So the end result is we end up with an output of an analysis. We get this breakdown for a control. We understand where it sits on the hierarchy of controls. We understand the organizational factors, and we understand the robustness of the control. We also understand the human dependency, in terms of how it rates from the user experience, and we also understand the human factors. And you get this broken down as well as what the increments are. We get an output for the alignment, and we also then get an overall score for the control, and then we end up with a system of being a final overall rating for the control, from being very low effectiveness through to being highly effective as such. And in essence, what you end up out of this process is for each control, you'll end up with a control effectiveness score. Now, this is the information that goes back to the executive, and they'll see it in a form like this for the list of critical controls. And so you might take a material risk and you can present the critical controls, and you can give a breakdown then of overall, what the control effectiveness is. And that gives an indication of where attention should be paid to thinking about redesign or changing the control. If you've got controls down around the 2.5 level, then you need to put some attention into that. So this is giving them a very different input from our traditional risk assessment of saying we've got a control in place and the residual risk is very low as such. Now, this process becomes a continuing process. The idea is, if we think about it in practice, once we have this information in controls, we constantly feed that back into the design process. So constantly go out to the field, take input from how the control has been performing. We find the data is very different in different organizational operational settings, and that you constantly use that information to bring that through your engineering process. And that, this is, the model of, thinking about resilience engineering, and this concept process, thinking about how do we plan and build design, how well do our controls respond in this, how do we get, get some information, take it back in the redesign process, and then how do we learn and adapt and take it back into the start of the process for how we do the work as imagined, taking the input from the work as done in that space. So this is, when you think about this method, this is the summary, of using design thinking in the control space. Is thinking, we understand our material risks. We go through a process of identifying the causal pathways, and then we go through and engage this process through the design. So when I was saying earlier about the subject matter experts having better information, that's what we're then looking at through this design process, is taking the information through control effectiveness, which is come from the engage and listen component, which is where the control effectiveness is done. And that gives the information is, well, let's reframe and redesign the control based on those inputs. And again, we would recommend that is done harnessing, input from those that do the work, being involved in that design process, go through a process of iterating, testing and building, adapting controls. And once you've got an idea that that's working or not working, you'll go through another strategy. But if it is working, you'll launch and scale the process. So it becomes a constant design process. So Sarah, that probably brings me to the point where it'd be good to take some questions or discuss the material. As you know, I can't see the chat on my screen, so very happy if you're able to bring anything through or raise anything you would like me to follow up.
Sure. Well, I would invite people to use the Q&A panel to ask questions, and we'll hopefully be able to deal with them. There is a chat. Okay, it's from Carolyn, and she just said, "Love it, thank you." So it's nice. There was a question by email from a person called Valerie.
I might stop sharing my screen. I might be able to see the chat then, so I'll try that. Okay, I can see the chat now.
Okay,
which is very easy. Thanks, Carolyn, for feeding that back. If anyone else wants to put a question into chat, I can also have a look at Q&A, see if there's anything there. No, I've got no open questions at the moment.
There was a question by email.
It's a very quiet session.
Kelvin, there was a question by email. Did you hear that? Hello, can you hear me? I don't think you can.
I can check back, Sarah, just seeing whether there's anything that's come through to you.
I don't think you can hear me. Oh, I don't know if anyone else can. Can I ask people in the chat panel if they can hear me? Because I may have lost speaker.
I've got it. Oh, great. Some questions coming up. Thanks. Yeah, where can you learn more about this? You can certainly contact us, and I think Sarah will share a link after the process. And you can contact me directly. Also, Thomas, happy to do that. Yeah, we can share, some of the experience. We've been working with a number of organisations across this, looking at large miners and across in industries like defence and construction and the like. So happy to share that experience as well. And Thomas, it might be just you and I on the webinar. Okay, I think I've got some more in chat, so I'll try that. Oh, great. Right, Louise is there. Yeah, everyone can hear me, which is fantastic. That's great. Right, so I was just saying that I can't hear Sarah, but that's fantastic. Yeah, look, if there's any other questions, please put them up into chat. Yep, no, I've got the message from Sarah. Okay, I've got a message, a question from James. Does this approach require quite prescriptive controls rather than performance outcome-based controls in order to be reliably assessed? No, look, that's the interesting nature about this is you can have quite a sophisticated control in the design process, and it sort of lends itself into that space because what it's allowing you to do is taking all of the elements in place, and not just the critical control itself can be quite constrained, but when you look at the supporting elements around that, this will bring that information into play. So I think it is quite well suited to trying to understand the more complex nature of controls and how they interface with how the work is actually done in that space. Yeah, so Sarah has asked me, we had a question about performance measures, and that was submitted by email. And really, so in the essence, when we look at the resulting control effectiveness scores, this allows us to actually build KPIs around this space. So we can start to can put KPIs around the level of control effectiveness that you have for a given risk or a given geography or a given work activity that sets it into place. So it actually sets itself quite nicely into that space. And you can also put some supporting performance measures, particularly as you can get some breakdown about the human factors elements and how well they're performing in that space. What you might find, for example, that the control strategy is being compromised, by poorly designed human factor elements, and it'll give you an indication as to what those human factor elements are. And again, you can certainly drive that by have performance indicators in place to see, to set the stage of what you should be sustaining your control effectiveness at in those different domains. Okay, Louise has asked the broader question, and I'm not sure I'm going to have the easy answer, Louise, to that. Is when you're bringing into a new company, what we generally recommend is to try something small in the space. So, and this is not a bad space, like something in the critical control piece, because when you use this sort of technique, you're using some of the elements of safety differently, but you still got a lot of that safety one sort of structure and component around it, and it can be easier to take an organization in with thinking about that control process. But the second way is thinking in this space is we like micro experiments in particular. Try a small learning team, something like that. The learning teams, I think, are a really good way to show how you can get a much richer and better response, from a safety challenge that you've got, and take it back as a case study in point, and that will often enable you to broaden out and explore, the broader concepts of safety differently. So we never recommend coming in and just trying to say, oh, we need to do it all differently now. I think it's always important to respect the culture and practice and the work that's been done and build upon it rather than substitute it. Okay, wish you luck on that journey, Louise. So, but feel free to reach out if there's anything we can do to help you. I see Sarah's put a message up there, I think, about the next webinar. And I think we've covered everything off now. Yeah, no, it looks good. So Sarah, I think that probably brings us to a conclusion, unless there's more questions. Thanks, Valerie. Thanks, Sarah. And thanks everyone who's been part of the webinar. And I hope you saw something a little bit different in this space, and we would be very keen, if anyone wants to explore this idea, very, very happy to have that discussion.